Hi everybody, welcome to our next deep learning video. This video will go over part 2 of your project, which is about something called the attention mechanism and fine-tuning. So first, high level, what is the attention mechanism? Well, to explain this, we have to remember about the convolutional neural networks and recurrent neural networks. Both of those techniques are relatively old, going back 30 or 40 years. And the attention mechanism is a very new alternative to those techniques. Attention was developed only about 5 years ago, and really just in the last 2 years, it's become extremely popular in a form called the transformer architecture. Whoops, let's scroll back up. The attention mechanism and transformers, you should think of those as almost synonymous with each other. Attention is, when somebody uses the word attention, they're typically combining the attention mechanism with a recurrent neural network. And if somebody uses the word transformer, then they are using attention all by itself without a recurrent neural network. So we'll talk about that in detail a little bit later. The other thing this project is about is something called fine-tuning. And in fine-tuning, what we're doing is we're taking a really complicated model, probably one that Google or Facebook or one of these big companies has trained and spent thousands, possibly hundreds of thousands of dollars training this model. We're taking that model and adapting it for our specific tasks. So we're sort of reusing all of that expensive computational work that they've already done. And in this case, we're applying it to the coronavirus task. And because we're using the fine-tuning technique, you'll be able to use these really powerful architectures and train them just on your laptop. Okay, so let's get into the details of this assignment. There's a new data set that we'll be using. You can click here and download it. Notice that I'm not going to be giving you as detailed instructions about how to do things in this part of the project. The instructions will be at a little bit of a higher level, and my expectation is that you'll start to be able to figure out these nitty-gritty pieces by yourself, like where should you download this to, and how you're actually going to run your names.py file to use this data set. If you do have questions about any of those things, definitely post an issue in GitHub and I will do my best to answer. But you can also reference the details in part 1 to see how to do those things. Okay, so what's interesting about this data set is that it's a multilingual data set. The previous data set was only in English, but this one is in 10 different languages. So English, but then also Spanish, Portuguese, Italian, French, German, Russian, Chinese, Korean, and Japanese. So these 6 languages are all relatively similar to each other, all European languages using the same Latin script. Spanish and Portuguese and French and German all have some extra characters that English doesn't have, but it's all very, very similar. Russian has totally different characters though, same with Chinese, Korean, and Japanese, and so we'll need new techniques for dealing with these languages. And the next videos will go through some detailed examples of what's tricky about these languages and how to work with them. So there's 10 languages in this data set, and for each of these 10 languages, I've selected 10 prominent news sources to be in the data set. In total, there's a little over 100,000 headlines, and so that's about 1,000 headlines per news source in the data set. So the model that we're going to be using is a model called BERT, and BERT is one of these transformer models. So again, transformer is like this attention mechanism, and we're going to be using a library called transformers. And again, the next video goes into detail on how you actually use the transformers library. But I'm going to drive this point home because this is really important. the Transformers library is a super popular library. It's exploding in popularity for natural language processing, and it makes it really easy to do fine tuning on any sort of transformer architecture. There's at least a dozen of these architectures out there now, more coming out every month, and this library makes it really easy to use those architectures and get really, really good results for whatever problem you're working on. If after graduating you are doing some machine learning sort of work at a company and that involves natural language processing, then you want to use this Transformers library because it'll make getting good results really easy. Okay. So again, the next videos we'll talk about how to use the library. Right now I just want to talk about what you need to do for this assignment. So the first part is you have to add the multilingual BERT model into your names.py file. And again, I'm not going to, you have a lot of flexibility and freedom and how to do that. The next videos explain all the details of how to use the Transformers library, but you can feel free to put those into the names.py file in whatever way makes sense to you. Okay, for our the requirements of your performance of your model. So you'll have to train one of these BERT models where you get accuracy at 1 that's at least 0.3 and accuracy at 20 that's at least 0.9. So recall that our task is given a headline, predict which host name, which domain name that headline goes with. And the accuracy at 1 is sort of like the actual accuracy, the very top thing that we predict, is it correct or not? And so you have to get at least 30% accuracy. I was able to get 60% accuracy, so this is, I think, a very conservative number. And then the accuracy at 20 is that if you take the 20 highest ranking options or predictions that your model predicts, if the true host name is in those top 20, then you get a 1, otherwise you get a 0. And so you should be able to get at least 0.9. I was able to get like 0.999, like indistinguishable from 100% on this task. If you click right here, I'm showing you the my runs from tensorboard.dev, and so this is the accuracy at 1 up here. See, I'm just shy of 0.6 on the third iteration. And then down here, accuracy at 20, it's like, yeah, indistinguishable from 1.0. In this task, yeah, so I want to emphasize this loss underscore next cares. You're not able to train this thing with the BERT model. There are other transformer articles for predicting sequences, for generating sequences. The model GPT-2 is the most famous one, and the Transformers library does have GPT-2 built in, making it really easy for you to do that if you wanted to. But for this task, we'll be ignoring the lost next characters, just set that equal to 0, and you only want to train on the ability to predict the next class. Okay. Yeah, so to get these numbers, you'll have to experiment with a bunch of different hyperparameters. I don't care what sort of parameters you pick, whether you use gradient clipping or not, whether you use different learning rates or not, whether it's Atom or SGD. I'm not even requiring that you do multiple warm restarts to get good performance. Just however you can get these numbers, if you get them, then you're good. And then the last thing, you'll have to generate a tensorboard.dev plot of your results, and that's what you submit to Sakai. You do all that, you get 100% on the project. But there's this one optional task of the explanation code that we did in part one of this, part one up here. If you also make that work on this BERT model, that would be really cool, because then you can compare your original character level recurrent neural network to this BERT model and see which sort of headlines one does better at than the other. Okay, yeah, that's everything for the explanation of sort of what you're doing in this part of the project. The final part of the project will build on the model you're developing for this part of the project. So, and in particular, if you get really good accuracies, then you'll get really exciting results in part three on embeddings. In this part, we will actually be able to see really well which host names are spreading news that is similar to which other host names, even being able to look across the language barrier. So that's an incentive to maybe try to get accuracy numbers that are better than these. So that's it for this video, and I'll see you in the next videos where I'll explain exactly how to use this transformers library.